Alright, today we're going to look at verifying whether or not two functions are inverses. And this process is actually really simple. It involves the composition of the two functions in question. So first, when you're given two functions, you want to find f of g of x, or f of g, depending on the notation you want to use. And then you need to find g of f of x, and if they are both equal to x, then they are inverses of each other. So let's look at some examples. In example 1, we have f of x equals 4x minus 2, and g of x equals x plus 2 over 4. So let's start by taking f of g of x. So we are substituting the entire function g of x in for x in f of x. So once we have written it out, we want to go ahead and start to solve. So if you look here, the 4 in the denominator and the 4 on the outside of the parentheses are actually going to cancel out. And that's going to leave us with x plus 2 minus 2. And similarly, the 2 in the parentheses and the 2 on the outside of the parentheses, or the negative 2 on the outside of the parentheses, those are going to cancel out as well because they're like terms. And when we combine them, they equal 0. So our final answer here is x. Now, that doesn't necessarily mean that these are going to be inverses. We still have to verify that g of f of x is also equal to just x in order for that to be the case. So we're going to do the same thing, but here we are going to substitute 4x minus 2 in for x in g of x. So in the numerator, again, our minus 2 and our plus 2 are going to cancel each other out, which leaves us with 4x over 4. And then the 4's will cancel out, and that leaves us with just x. So because f of g of x is equal to x and g of f of x is equal to x, then that means that these two functions are in fact inverses. So let's look at another example. We have m of x equals x squared plus 5, and n of x equals the square root of x minus 5. So let's go ahead and do the first composition, m of n of x. So in the place of x, we are substituting square root of x minus 5. So when we square the square root of x minus 5, we are left with just x minus 5, and then the plus 5 on the outside. These two 5's are going to cancel out, leaving us with just x. But again, just because one composition is equal to x doesn't mean that the other one will be, so we have to check that one too. So n of m of x is going to equal x squared plus 5 square root of that minus 5. So under the radical, our 5 is going to cancel out with the negative 5, and that leaves us with the square root of x squared. And the square root of x squared is just x. So again, we have m of n of x is equal to x, and n of m of x is also equal to x, so that means that these two functions are inverses of each other. Okay, let's look at one more example. So we have g of x equals 5x minus 7 and h of x equals x over 5 plus 7. So let's first do g of h of x. So in the place of the x, we are plugging in x over 5 plus 7. We need to distribute the 5 here. In the first term, those 5s will actually cancel out, leaving us with x. And then when we distribute the 5 to the 7, that's going to leave us with a positive 35. So simplifying, we are left with x plus 28, which is not equal to x. So really we could stop here because in order for the two functions to be inverses, both compositions need to be equal to x, but let's do the other one just so we can see what that looks like. So we're going to plug in g of x in for x, and that's going to give us 5x minus 7 over 5 plus 7. We can break this fraction apart into 5x over 5 minus 7 over 5, so that we can cancel out the 5's in the first term, but we're still going to be left with x minus 7/5 plus 7. So this is also not equal to x. So that means that these functions are not inverses.